Hello everyone, welcome to my channel Ganitha Vahini. I am HarshaVardhana. In previous session, we have discussed about the conjugate and modulus and properties of a complex number. In this session, we are going to discuss the problems based on conjugate and modulus of a complex number. Here, the first problem is that find the multiplicative inverse of a complex number root 5 plus 3i. We know that multiplicative inverse is the reciprocal of a complex number. Therefore, the multiplicative inverse of a complex number root 5 plus 3i is 1 by root 5 plus 3i. After that, we have to multiply this multiplicative inverse by the conjugate of a complex number. There, 1 by root 5 plus 3i into root 5 minus 3i by root 5 minus 3i. We get root 5 minus 3i by root 5 whole square minus 3i whole square. That is equal to root 5 minus 3i by 5 minus 9i square. That is root 5 minus 3i by 5 minus 9 into minus 1. That is root 5 minus 3i by 14. That is equal to root 5 by 14 minus 3 by 14 into I. We move to the next problem. If 1 plus I into Z is equal to 1 minus I into Z bar, then show that Z is equal to minus IZ bar. For this, here we start with the given equation, that is 1 plus I into Z is equal to 1 minus I into Z bar. After this, we isolate Z. Divide both sides by 1 plus I to express Z in terms of Z bar. Therefore, Z is equal to 1 minus I by 1 plus I into Z bar. After this, we rationalize the denominator. Here in this, we multiply the numerator and the denominator of the fraction by the conjugate of the denominator, which is 1 minus I. Therefore, Z is equal to 1 minus I over 1 plus I into 1 minus I by 1 minus I into Z bar. After this, we simplify the expression. In that, we first simplify the numerator, that is 1 minus I into 1 minus I is 1 minus 2i plus I square, that is 1 minus 2i minus 1, that is equal to minus 2i, since I square is equal to minus 1. Then after this, we simplify the denominator, that is 1 plus I into 1 minus I, that is 1 square minus I square, that is equal to 1 minus of minus 1, that is equal to 2. After simplification, we substitute the simplified values back into the equation. We get Z is equal to minus 2i over 2Z bar. Therefore, Z is equal to minus IZ bar. This completes the proof. We find another problem. Write the conjugate of 1 minus I over 1 plus I. To find the conjugate of the complex number 1 minus I over 1 plus I, we follow these steps. In step 1, we multiply the conjugate of the denominator. We start with the expression 1 minus I over 1 plus I. To simplify this, we multiply both numerator and the denominator by the conjugate of the denominator, which is 1 minus I. That is 1 minus I into 1 minus I over 1 plus I into 1 minus I. After step 1, we move to the step 2. In this, we simplify the denominator, that is 1 plus I into 1 minus I. that is 1 square minus I square, that is equal to 1 plus 1, that is 2, because I square is equal to minus 1. After this we simplify the numerator, that is 1 minus I into 1 minus I, that is 1 square minus 2I plus I square, that is equal to minus 2I, because I square is equal to minus 1. In step 4, we combine the results from numerator and denominator, minus 2I by 2, that is equal to minus I. The conjugate of a complex number a plus bi is given by a minus bi. In our case, minus z is equal to minus I, that is equal to 0 minus 1I. That's all for this session. Those who have any doubts or clarification in this above video or in this chapter, put the comment in the comment box. I will rectify the same. Those who like the video, subscribe the channel, and those who didn't witness the video, I will put the link in the description box. You click on the link and see our previous videos.